Students, welcome back. This is 10th grade triangles exercise second, third question. Last video we have discussed 1 and 2 problems. Here, if LM parallel CB and LN parallel CD, prove that AM by AB is equal to AN by AD. You can see here AM by AB. You can just watch the figure and AM by AB is equal to AN by AD. So LM parallel CB. So we can write LM parallel CB in triangle ABC. In triangle ABC. Apply BPT by BPT basic proportionality theorem. We can write AM by MB is equal to AL by LC, or we can write AM by, because our answer we need to get AM by AB. So we will write AM by AB is equal to AL by AC. So AM by AB is equal to AL by AC. Okay, so we have learned last problem AM by MB is equal to AL by LC. This both are same. You can say AM by AB is equal to AL by AC. This is equation number 1. Second case, LN parallel CD. LN parallel CD in triangle ADC. Apply by BPT, we will get AN by, same way you can apply AN by AD is equal to AL by AC. This is equation number 2. You can see equation 1 and 2, this part is same, RHS is same. So by 1 and 2, equation 1 and 2, you will get AM by AB is equal to AN by AD. Hence the answer. So when you are doing the problem, first you want to write given. Okay, then you can write to show this AM by AB is equal to AN by AD. If there is an extra construction, extra drawings, that also you have to note it down. Okay. This is fourth question. In figure, DE parallel AC and DF parallel AE, you want to show this. So given, we can write step given DE parallel AC and DF parallel AE. Okay, to prove or to show it is BF by FE is equal to BE by EC. Okay, so we can consider DE in triangle DE parallel AC. That means in triangle ABC, DE parallel AC. So by BPT, you will get in triangle ABC DE parallel AC. You can get BD by DA is equal to BD by DA is equal to BE by EC. BE by EC, equation number 1. Here we took like that because you can see in the question, prove that BF by FE, BE by EC. Not last problem we got what is whole side. Okay, that's why we selected like that. Now as per the question we have to select. Okay. So then second part is DF parallel AE in the triangle. In triangle, what is ABE? Apply BPT. We will get BD by DA is equal to BF by FE. Okay, this is equation number 2. You can see equation 1 and 2 LHS are same. LHS are BD by DA. So if LHS are same, from 1 and 2 we get we get BE by EC is equal to BF by FE. FE or BF by FE is equal to BE by EC, hence the proof. Question number 5. Here we have to show EF parallel QR. If it is given DE parallel OQ and BF parallel OR, EF parallel QR. That means we have to use the converse of BPT. If lines are parallel, then the sides are in the same ratio. That is the converse of BPT. So let us do it. So as per the rule of the problem, you have to write given, then consider. Okay. So given DE parallel OQ and DF parallel OR, then show that we will do EF parallel QR. So we can consider, then starting solution, consider triangle ED parallel DE parallel OQ in triangle PQO or POQ. In triangle PQO, we will get by BPT, you will get it PE by EQ is equal to PD by DO, equation number 1. Then from the second, DF parallel in OR, in triangle POR, in triangle POR or in triangle PRO, in triangle PRO, we will get it by applying BPT. We will get PF by FR is equal to PF by FR is equal to PD by DO, equation number 2. 1 and 2 RHS are same, so by using 1 and 2, we will get PE by EQ is equal to PF by FR. This is, you see, PE by EQ is equal to PF by FR. In the figure you can see PE by EQ is equal to PF by FR means by converse of BPT, by converse of basic proportionality theorem, EF is parallel QR. So, by after this you can write, so by converse of BPT, EF parallel QR, hence the proof. The sixth problem. In figure it is given that A, B, C are the points on these sides and AB parallel PQ, AC parallel PR. We have to show BC parallel QR. So here given AB parallel PQ, given AB parallel PQ and AC parallel PR. Show that BC parallel QR. So this is also by converse of BPT we will get it. In triangle of PQ, solution, in triangle of PQ we know AB parallel PQ. By BPT, by basic proportionality theorem, we will get OA by AP is equal to OB by BQ, equation number 1. Then in triangle OPR, in triangle OPR, we know AC parallel PR, AC parallel PR. Then by BPT, apply BPT, OA by AP is equal to OC by CR, OC by CR. So we got, this is equation number 2. From 1 and 2 LHS part is same. So by considering 1 and 2, OB by BQ is equal to OC by CR. You can see in the figure OB by BQ is equal to OC by CR. So by converse of BPT, you will get BC parallel QR. Hence the answer. This is the seventh question. Using theorem 6.1, prove that the line drawn through the midpoint of one side of a triangle parallel to another side bisect the third side. Recall that you have proved in class 9. So here given AP is equal to PB. Here P is the midpoint of AB and PQ parallel BC. To prove AQ is equal to QC, or Q is the midpoint of AC. So let us start the solution. Here PQ parallel BC means by BPT you can write AQ by QC is equal to AP by PB. You know P is the midpoint. P is the midpoint. So we can write AQ by QC is equal to 1 by 1 over 1. If P is the midpoint, we can write 1 by 1. That means you will get by cross multiplying, or 1 by 1 means 1 itself. So AQ is equal to QC. Then Q is the midpoint of AC. Hence the answer. Using theorem 6.2, prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So it is given that AB is equal to PB and AQ is equal to QC. That means P and Q are the midpoint of AB and AC. To prove PQ parallel BC. So we know if AP is equal to PB means AP by PB is equal to 1 by 1 or 1 you can write, and AQ by QC also equal to 1. That means we will get AP by PB is equal to AQ by QC. So by using BPT, converse of basic proportionality theorem, we will get, so PQ parallel BC, you can write in the bracket by converse of BPT, okay, or by BPT, that's enough. Okay, thank you for watching.